This is a video from Math 386, and it's on exponential functions. An exponential function is a function that can be written in the form f of x equals a to the power x. Note, a is greater than 0 and a doesn't equal 1. Now, what I want to do is I want to look at some characteristics of exponential functions. So, number one, the domain. Think of the domain as all the possible values of x that the function can take on. So, in other words, all the possible inputs. The domain is negative infinity to infinity. Number two, the range is from 0 to infinity. Number three, the y-intercept happens to be 0, 1. So when x is 0, the corresponding y value is 1. Number four, f of x equals a to the x is continuous. On negative infinity to infinity. If a is bigger than 1, f of x equals a to the x is increasing. Okay, let me write that. Now, if a is between 0 and 1, f of x equals a to the x is decreasing. And I got one more property I want to go over with you. Number 6. If a to the x equals a to the y, then it follows that x has no choice but to equal y. Conversely, it turns out if x equals y, then a to the x must be equal to a to the y. And this is one I'm going to take full advantage of for several examples. Now, let's come over here, and the directions say to solve each exponential equation. Okay. So let's take a look at number 1. And number 1 is 2 to the x plus 2 equals 64. And your goal is you want to rewrite both sides so that they have the same base. Now, let's take a look at 64. 64 is equal to 2 times 32. 32 is equal to 2 times 16. 16 is 4 times 4. 4 is 2 times 2. And then 4 is also again 2 times 2. Right? If I count up all these 2's, I get 1, 2, 3, 4, 5, 6. So it turns out that 2 to the x plus 2 is equal to 2 to the 6, which says x plus 2 must equal 6. If I solve for x, I get x equals 4. And that's how you do problem 1. Let's take a look at problem 2. Suppose 8 to the x is equal to square root of 2. Now, I'm going to write this as 2 to the third raised to the x equal to 2 raised to the 1/2, right? So again, I'm rewriting each side so that they have the same base. But that says 2 to the 3x is the same as 2 to the 1/2. So now we share the same base. I could then say 3x equals 1/2. Now, I'm going to divide both sides by 3. So 3x over 3 is the same as 1/2 divided by 3. So x is 1/3 multiplied by 1/2, which is equal to 1/6. And that's how you do number 2. Let's take a look at 3. So 3 to the x is equal to the cube root of 9. Same goal. You want to rewrite both sides so that they have the same base. Now remember, 9 is equal to 3 squared, right? So we can write this as 3 to the x is the cube root of 3 squared, which says 3 to the x equals 3 to the 2/3, right? This is a property here. If I take the nth root of a raised to the m power, we could write this as a raised to the m over n. And so here, x has no choice but to equal 2/3. And that's how we do number 3. Now, we have to skip 4 for now, and I'm going to go over number 5. Number 5 is 7 to the 5x equals 1. But that says 7 to the 5x must equal 7 raised to the 0. Anything raised to the 0 is 1, right? Now both sides have the same base, and what we can say is 5x equals 0. Solving for x, we get x is 0. Okay. Number 6. I'll just put that here. So if I have 5 to the 2x minus 3 equal to 25. So 5 to the 2x minus 3, well, that's the same as 5 squared. So 2x minus 3 equals 2. It has no choice. So if I add 3 to both sides, right, I get 2x equals 5. Solving for x, I get x equals 5/2. So your goal the entire time is to rewrite both sides so that they share the same base. Let's take a look at 7. On number 7, we have 4/9 to the x is equal to 3/2 to the -6. Now, two things to keep in mind. 4/9 is equal to 2 over 3 raised to the 2nd, okay? That's for starters. So I'm going to take 2/3 to the 2nd, and then I'm going to take that and raise it to the x power. Now, on the other side, we get 3 to the -6 divided by 2 to the -6. So now, I'm going to take 2/3 to the 2x. That's on the left side. I'm going to move this denominator up, but when you do that, you have to change the sign of the exponent. And I'm going to take this numerator and move it down. Same thing, I have to change the sign. So, in other words, this is going to be 2 to the 6th divided by 3 to the 6th, which says 2/3 to the 2x is 2/3 to the 6. So we have the same base. That's what you want the entire time, okay? So 2x equals 6. Divide both sides by 2, and we get x equal 3. And we're done. So that's how we do number 7. We could take a look at number 9 here. So if I have 7 to the 5x over 2 on the left side, and then I have the 5th root of 343 on the right side. So I'm going to write this as 7 to the 5x over 2 equals 343 to the 1/5. Now, in my mind, I want to see if I could rewrite both sides to have 7 as the base, right? So I'm going to take 343, and I'm going to do this factor tree thing here, right? So I'm going to put a 7 here. Then I'm old school, so I'm going to go 7 into 343. 7 goes into 34 4 times, right? I'm going to put 28 here because that's what 4 times 7 is. I'm going to get 63, and then I'm going to put a 9 here. So that looks like it's 49. So if you don't mind, I'm going to erase this part. And I just happen to know 49 is 7 times 7, okay? So I'm going to get 7 to the 5x over 2 on the left side. On the right side, I'm going to get 7 to the 3rd, and I'm going to raise that to the 1/5 power. So 7 to the 5x over 2 is 7 to the 3/5, because that's what 3 times 1/5 is. Now, the exponents match, right? So 5x over 2 is 3/5. Would you guys be okay if I cross multiply, right? When I cross multiply, I get 25x equals 6. Solving for x, I get x equals 6 divided by 25. And that's how we do problem number 9. Let's take a look at problem 11. So on problem 11, we have 2 to the 5x minus 2 equals 2 to the x minus 3. So I'm going to match the exponents here. So 5x minus 2 is x minus 3. So I'm going to subtract x on both sides. When I do that, I get 4x minus 2 equals negative 3. I'm going to add 2 to both sides. And so I get 4x equals negative 1. Solve for x. I get x equals negative 1/4. Boom. That's how we do problem number 11. Let's go ahead and take a look at 12. I'll put that over here. So on number 12, we have 5 to the 4x minus 6 equal to 25 to the 3x minus 5. So same game, right? There's a couple ways we can do this, but I think the more natural way is to take the 25 and call it 5 squared, I believe. So 5 to the 4x minus 6 is 5 squared to the 3x minus 5. So 5 to the 4x minus 6 on the left side is 5, And then I'm going to take 2 times 3x minus 5, and I'm going to get 6x minus 10. I hope that's okay. So in other words, I took the 2 times the 3x and the 2 times the 5. Now set these exponents equal to each other. Okay. Now, subtract 6x on both sides. And when I do, I get negative 2x minus 6 equals negative 10. Add 6 to both sides. And so negative 2x equals negative 4. And then if I solve for x, I get x equal 2. And that's how we do problem number 12. Let's take a look at a couple more. So we'll do 13. So if I have 8 to the x times 2 to the 6x on the left side, and on the right side we have 4 to the 2x plus 10, okay? So 8 is 2 cubed. And then we get 2 to the 6x. And then remember 4 is 2 squared. So we get 2 squared to the 2x plus 10, like so. So I'm rewriting both sides to have 2 as the base. So 2 to the 3x times 2 to the 6x on the left side. And then I'm going to distribute the 2 in. And I'm going to get 2 to the 4x plus, I believe that's 20, right? So 2 to the 9x on the left side, and then 2 to the 4x plus 20 on the right side. So 9x is 4x plus 20. So I'm going to take 4x over to the other side. And then when I come over here, I get 5x equal 20. And then x is 4. And that's how we do 13. So I got 2 more in mind for you. So we're going to do 14. So this one's interesting because we're going to do 4/3 to the x minus 1 times the square root of 3/4. That's on the left side. On the right side, we get 2 divided by the 4th root of 3. And I'm going to raise this to the 3x minus 4. Okay, so couple of comments. Now, remember that square root of 3/4 is 3/4 to the 1/2, right? That's for starters. If I take this 4/3 and write it as 3/4, what I essentially need to do to that exponent is change the sign. So in other words, this is going to become 1 minus x. So I get 3/4 to the 1 minus x times 3/4 to the 1/2 on the left side. Okay? Now, on the right side, I'm going to get 2 over. Now, 4th root of 3 is 3 to the 1/4. And I'm going to raise that to the 3x minus 4. Like so. Okay? I hope that's okay. Now, I have 3/4 to the 1 minus x times 3/4 to the 1/2. That's going to be 3/4 to the 1 minus x plus a half on the left side. On the right side, I get 2 over, now this is going to be 3 to the 3/4 x, right? That's what 1/4 times 3x is. And then 1/4 of 4 is 1, so it's minus 1. So I get that. Now, here, I'm going to get 3/4 to the 3/2 minus x. Because remember, 1 plus a half is 1 1/2, which is equal to 3/2. That's the left side. On the right side, let me just copy it down. We get 2 over 3 to the 3/4. Let me give a little bit of room here. So it's 2 over 3 to the 3/4 x minus 1. Like so. Here's another comment here. It turns out 2 is equal to the square root of 4, right? So I'm going to do something sneaky on you guys. So I'm going to go 3/4 to the, it's 3/2 minus x on the left side. And then I'm going to go square root of 4 divided by. And then I'm going to get 3 to the 3/4 x minus 1. 3 to the 3/4 x minus 1. Now, notice here, so 2 things. I'm going to swap places again. So I'm going to go 4/3, and I'm going to change signs. So it's going to be x minus 3/2. And then I get square root of 4 divided by 3 to the 3/4 x minus 1. So I'm going to do one last sneaky thing on you guys. So I'm going to take this and write it as 4 to the x minus 3/2 divided by 3 to the x minus 3/2 on the left side. On the right side, I get 4 to the half divided by 3 to the 3/4 x minus 1. Now, notice how the numerators have the same base, the denominators have the same base. So what I'm going to do is I'm going to set x minus 3/2 equal to 1/2. If I solve for x, I get x equal 2. Now, if I check, and if I did everything right, I'm going to take x minus 3/2 and set it equal to 3/4 x minus 1, right? So I'm going to multiply both sides by 4. That's going to clear the fraction, okay? And so 4x minus 6 is the same as 3x minus 4. And I claim when I solve for x, I'm going to get x equal 2. So notice how I got the same thing solving this equation, right? So in other words, setting these exponents equal and then setting these exponents equal. This one's a tough problem. All right, that's a good stopping point, in fact. So this is a video on solving exponential equations, and we did probably at least 10 examples. So, okay, thank you.